Hello everybody, welcome back. In this video, I'll show you how to graph sine and cosine in some more complex instances. So let's jump right in. Alright, so I'd like to show you something which is y equals a times the sine of b times x plus c plus d, and y equals a times the cosine of b times x plus c plus d. Now a equals our amplitude, which is our vertical stretch. So let's say we graph a function like this. Amplitude is the vertical distance between the midline and its longest sort of points. We can use b to find out the period using this formula. Now what about c? C is the horizontal shift, and d is our vertical shift. Alright, let's try and graph y equals 3 times the cosine of 2 times x plus pi over 2. Now what's the amplitude? Well, we have a right here which equals amplitude, and a is being multiplied by the sine or cosine of blah blah blah. And we have 3 multiplied by the cosine of 2 times x plus pi over 2. So we can conclude that 3 is our amplitude. And remember, the amplitude is the vertical stretch. It's basically, let's say there's a graph like this. If you up the amplitude, is basically, let's say the midline was here. The amplitude is the distance between the midline to its highest points and lowest points. So if we up the amplitude, it could look like this. Upped it even more, it could even look like this. Now what's the period? Well, the period equals 2 pi divided by b. What's b? Well, b is in the of part of the cosine of blah blah blah, and it's being multiplied by these parentheses. And right here we have 2 multiplied by the parentheses. So we know that our period is 2 pi over 2, which equals just pi. So our period is pi. I've marked our period into 4 parts, just so that's easier to graph. We have this plus pi over 2. What we're saying is we're going to take pi over 2 on this side, and you see how much distance it covers? It covers this much distance, which means we're going to replicate that on the other side, because we're adding it. So you can think of it as moving the y-axis to the left. But remember that we're not actually doing this. You can just imagine it that way. We're not actually moving the y-axis to the left. You can just imagine it that way. So now we have a new starting point, which is right here. Now I'm going to draw an imaginary y-axis. Now, do we have a vertical shift? Well, d equals the vertical shift, and plus d comes after the parentheses. And we don't have anything after the parentheses. Let's look before it. Nope, we have 2 times it. Yeah, we don't have anything. We can just assume it's plus 0, which won't affect this at all. So now it's time to graph our function. And so remember that we have an amplitude of 3. And here's our work. Except it's quite messy, so if we shine it up a bit, it will look something like this. And here's our graph, and it's looking pretty neat. Alright, so let's try and graph y equals sine of 2 pi divided by 3 times x plus 3 divided by 2 plus 2. And what's our amplitude? Well, our amplitude is 1, because 1's being multiplied by this, because there's not really anything right here. So we can just assume our amplitude is 1. Now our period. Well, the period equals 2 pi divided by b. B is being multiplied by the parentheses. 2 pi is being divided by 3 is being multiplied by the parentheses. So we have 2 pi over 2 pi over 3. And instead of dividing, we can just multiply by the reciprocal. Sorry about that 3. We can do 2 pi over 1 times 3 over 2 pi. And what we get is 6 pi over 2 pi. Now the pi's cancel out, And 6 divided by 2, it equals 3 over 1, which equals 3. So our period is 3. Alright, now I've made some of the tick marks. Now, we have this plus 3 halves. Now, 3 halves is right here. If we add 3 halves, we're going to be shifting the y-axis to the left to negative 3 halves. But remember, we're not actually shifting it. We can just imagine it that way. Because we can imagine it that way, we can draw an imaginary y-axis right over here. Alright, now we have this plus 2. And what this is going to do is we're going to go up 2 on the y-axis. So we're going to go all the way up to right here. So we can draw an imaginary x-axis, which means that this right here is our starting point, which means that our graph is going to look like this. We're going to go up, down, down, up, and then we could graph even more cycles if we wanted to. And this right here and this right here marks where we have one period. And if I erase all this messy work, we have this. And one period with the first part of it would start here, and the second part of it would end like right here. And this right here is one period of y equals sine of 2 pi divided by 3 times x plus 3 divided by 2 plus 2. Alright, so let's try and graph y equals negative 3 times the sine of 4x plus pi minus 1. So what is the amplitude? Well, we have negative 3 in front of sine and a in front of sine, and amplitude equals a. Right, now what's this period? We have this 4 right here, and this x, and this plus pi, so let's try and factor out a 4. Alright, so now this looks like it's an easier format. So now we have a 4 right in front of the parentheses and a b right here in front of the parentheses, and the period equals 2 pi divided by b. So now we can write 2 pi divided by 4, which can be simplified to 1 pi divided by 2, which can be simplified to pi divided by 2. Alright, so you can see that I wrote some tick marks on the x-axis. For some reference, what is the horizontal shift, or in other words, the phase shift? Well, we have a I over 4 right here, and we have a C right here, and the C equals the horizontal shift. So our horizontal shift is plus pi over 4, right? So you can see that pi over 4 takes up this much distance. So we're going to replicate that on the negative scale. So now we're right here. All right, and now we have this minus 1 right here. And we also have this D right here, and D equals the vertical shift. So our vertical shift is minus 1. And now we're going to go down here. And now we can write an imaginary x-axis. And now we're just going to graph our sine graph, but also remember that we have negative 3 sine, and normal sine would look like this, but negative sine is going to flip it. So it's going to look like this. And it's times 3, so it's really going to look something like this. It'll look pretty extreme. Alright, and here's our graph with a bunch of messy work. And here's our graph with a bunch of clean work. And we've now graphed one cycle of y equals negative 3 times the sine of 4x plus pi minus 1. Thank you so much for watching. If you enjoyed this video, please give it a thumbs up and subscribe to my channel and hit that notification bell. If you disliked this video, please show it